it is time to move on to Gauss-Jordan elimination. Now what we are going to be producing is called a reduced row echelon form matrix. The last time we saw a row echelon form matrix, and reduced just means there's a few extra steps. So here are the rules. The first non-zero number in the first row is a 1. That's the same as row echelon form. So first non-zero, we have a 1 here, 1, 1, and so on. Next, the first one in a row must be further to the right than the previous row. That's the same as row echelon form, right? So here I have a 1, and it has to be to the right of it. We cannot have a 1 and then a 1 underneath it or to the left. So it has to be like a ladder. The leading entry in each row must be the only non-zero number in its column. So this is a little bit different because now everything above and below the 1 have to be zeros. So in this column, you see that there's no 1. So these numbers can be whatever you want. But here we have a 1, and it means that there's zeros on top and zeros on bottom. Lastly, any 0 rows are placed at the bottom of the matrix. That's the same as row echelon form. So if this is all zeros, it has to be at the bottom. Now how do we do this? Well, for this one, we're going to go step by step. Step number 1 is to put all 0 rows at the bottom of the matrix. We just swap the rows. We've learned how to do that. That's pretty simple. Step number 2, we are going to multiply the top row by a scalar so that the leading entry is 1. This doesn't make sense, it should in a few minutes. Step 3 is going to be to add and subtract multiples of the top row to the other row so that all other entries in the column are 0. So we are going to do what we call zeroing out the column. Again, you'll see soon. And step 4 is to repeat steps 2 to 3 for the next leftmost non-zero entry. Let's go step by step. Here is our first set of linear equations. We have x plus y plus 7z is equal to negative 7, 2x plus 3y plus 17z is equal to negative 16, x plus 2y plus 5z is equal to 6. So we put this into augmented matrix form. Hopefully you all know how to do that. And it looks like this. If you are stuck here, you can go back to watch previous videos, but really make sure you know how to put it in an augmented matrix. We're going to look at this matrix now. The first row, let's find the first non-zero number, and it's right here. It's a 1. That's perfect. We already have that. Now we are going to zero out the column, meaning everything below and above this 1 has to be 0. So we have a 2 here and a 1 here. Let's start with the 2. To do that, we are going to take the entire row and we're going to subtract 2 times 1 from this number. So here we have 2. 2 minus 2 is 0. So 2 minus 2 times 1 is 0. And we do the same thing to the rest of the row. Again, if you're a little bit stuck on here, just take your time. Make sure that you do every number properly. So here we have 3 minus 2 times 1, and that is 1, and so on and so forth. Next, we have a 0 here, and we need a 0 here. How we do that is, well, 1 minus 1 is 0, so we can subtract this entire row by this entire row, and we get 1, 0, 0. Same thing here, we have 2 minus 1 is 1, 5 minus 7 is negative 2, 6 minus 7 is 13. Okay, we have this column done. That's great. Now let's find our next leading 1. So this row, we already have our 1 here. Let's go to the second row. The first non-zero number, oh, it's right here. And it's already a 1, so that's perfect. All we need to do is make this a 0 and make this a 0. Let's start with the top one. 1 minus 1 is 0. So let's do row 1 minus row 2. And that's what we have. So we have our 0 here now. Next, we want to make this number a 0. To do that, 1 minus 1 is 0 again. So this entire row by this entire row. And now we are left with this matrix. Again, you can pause, take a second, figure it out. We are moving on to our third and final row. So the first non-zero number is a -2. We do not want it to be a -2, we want it to be a 1. But what times -2 is 1? Well, -1/2 times -2 is 1. So that's what we mean by when we say multiplying by a scalar. So we don't want to add anything to this row, because if we add anything, these zeros will change and we want them to stay as 0. So when we multiply by -1/2, we get a 1 here. Now we're on to our last column. We have our 1 and we want everything above and below it to be zeros. So we have our 3 and we have our 4. Let's start with the 4. 4 minus 4 is 0. So 4 minus 4 times 1 is 0. We do that and we are done this row, we are done this row, and we only have 1 left. So here it is. We want to get rid of this 3. 3 minus 3 is 0, so 3 minus 3 times 1 is 0. Now what we are left with is our reduced row echelon form. So we have our 1's here, everything above and below them are 0, and then we have our answers. So just by looking at this, if this is an x, this whole column is an x, we know that x is equal to -31. We know that y is equal to 17.5. We know that z is equal to -13.5. So what's super helpful with Gauss-Jordan elimination is that you don't even have to rewrite the equations. You have your answers right in your reduced row echelon form matrix. Alright, if that was confusing, you should either rewatch it, try some extra practices, look up on Google some random matrices and try to figure out what its reduced row echelon form is. The next video is going to be about what we can do with matrices in terms of operations, so like addition, multiplication, all that good stuff.